Hello. Now we will calculate the moment of inertia for a rod, and this time the axis is passing through the rod itself. So I am having a linear object which is a rod, and this linear object mass is m and the length of the rod is L. And I want to calculate the moment of inertia for this rod about the axis which is passing through the rod itself, meaning all the masses, all the points onto the rod are lying onto the axis itself. So for this, the motion will be like this, meaning this is a rod and this kind of motion will be happening. If this is almost, its dimension is almost 0. Okay. So we have to cut the element. So let's start from the corner. So I'll start from the corner, I'll go for the x distance. I'll make a cut. Then I'll further go for dx distance, I'll make one more cut. The mass of this element, between these two cuts, I'm having an element, and mass of this element is dm. Okay. So let's first calculate the linear density for this rod. So linear density, which is defined as lambda, will be equals to total mass divided by L. Okay. This becomes the linear density for this rod. And while defining the linear density, I have assumed that density is uniform. I have assumed linear density is uniform while using this formula, otherwise I will not be able to use this formula. So while after calculating the linear density, I will be able to calculate the mass of the element. So mass of the element will be equals to linear density multiplied with length of the element. That will be equals to m dx upon L. Okay, this is the mass. This is equation 1. So after calculating the mass of the element, I will be using the formula for moment of inertia of this element. So you see, this element is a point element, and for all point element, we have a formula for the moment of inertia. This is the formula to calculate moment of inertia for a point elements. In this formula, if you can see, I is equals to mr square, where m is mass of the element, which is a point, and r is the distance of that element, point element, with respect to the axis. So my element is this. Okay, mass of this element is this, and the distance of the element with respect to the axis, that is 0. So though this element is at a distance x with respect to the corner, but in this formula, r is not the distance with respect to the corner. R is the distance of the element with respect to the axis. So value of r for this element will come out to be 0, because this element is at the axis itself. So distance of this element with respect to axis, which is 0, so r for this element will become 0. So if I use the formula to calculate moment of inertia for this element about the given axis, that will be equals to dm into r square, and if we put the value of r square, it will be 0. DIO will be 0. So the moment of inertia of my point element becomes 0. And if I want to calculate the moment of inertia for the whole rod about the given axis, that will be equals to integration of moment of inertia of the element, assuming we have to go for the whole body in this case. So you see, integration of 0 is obviously 0. So moment of inertia becomes 0. So whenever we'll be having a linear object like rod, and if the axis is passing through the rod, completely through the rod, meaning each point onto the rod is lying onto the axis, if that's the case, in that case, moment of inertia for this rod about the given axis will be 0. You can directly write the moment of inertia 0. And this is happening because each and every point onto the rod is lying onto the axis itself. Okay. So moment of inertia, we have calculated the moment of inertia of the rod about this axis, and that comes out to be 0. That thing we can memorize. Okay. Thank you.